So now in this video we're going to look at the LM747 op amp. That is a dual op amp. Basically it has two 741 op amps in there, and of course you should look at the data sheet for all the specifications, but for the most part it's similar to having two 741 op amps within it. And so it is a 14-pin integrated circuit, as you can see here, and the way I have this wired up is as two separate rail splitters. We have 18 volts at the rail, and you can see here that we have one of these resistors to the positive rail and then the other one to the negative rail. They both come to the non-inverting pin, and that sets the voltage that we desire. We use feedback so that as the voltage tries to change here because of load or whatever, it comes to the inverting input and tries to hold the inverting input to the same voltage as the non-inverting input. The outcome is that we have a fixed voltage here, which is halfway, because we have one resistor to the positive rail, the other to the negative rail, halfway of the power supply. So that gives us a virtual ground, because I have a just going to set this measure voltage, just one setting for this, it's an auto ranging, and I have a bench power supply providing 18 volts. As we will see here, there's 18 volts. And if I put the black probe to this jumper, which goes to the output there, I go to the positive rail, it's 9 volts. And if we go to the negative rail up here, it's negative 9 volts. Or we have this jumper here, we have to provide positive voltage to each of the op amps, but they share a ground, a 0 volt reference, or the negative rail. So this is not ground, this is the negative rail. And so we have to put the full power across the op amps. The halfway point is at the outputs. Now, the wiring for the output is 3 pins away from the end. So the inverting input is at the very end on the left side. Non-inverting pin is the second pin away from the end, and then there is an offset pin there that we're not going to worry about for a while. But in the middle, the fourth pin going up or the fourth pin going down, because there's 7, is our negative rail. And I got a jumper there. And so the output is 3 pins from the end on the right side, and then this one too, 3 pins down from the end there. So 2 pins down, we have the positive supply, and then 2 pins up over there we have the positive supply. So they're mirror images of each other. At the very end is another offset null pin, which I don't have any circuits that are particular enough where I need to worry about that so far. So hope to come up with some in the future. So now, another thing, I think I finally did find an op amp that does not have short circuit protection. But this one does have short circuit protection according to the data sheet. Always go by the data sheet. Don't just believe what people say. But according to the data sheet, it's unlimited protection. So we're going to go to milliamps, and the power supply, you're going to hear it clicking. I'm going to short circuit this, but only because I know the power supply is limiting current. Don't do this unless you're absolutely sure the power supply will not provide more current than what you intend to measure by the setting there. Otherwise you might blow a fuse if it sets more current. But you're going to hear the power supply click. That's because it's rapidly changing how much current's providing. So I set it to a maximum of about 500 milliamps of current, about that. And so what we're going to do, we're going to put the black probe here and look at the short circuit protection. So according to the data sheet, it was 25 milliamps of current short circuit to either rail. And so we're going to come here, and you can see it's a little bit more. Looks like it's going down though as it warms up. So that's the positive rail. So there was a 9 volt difference there. 9 volts more positive than our virtual ground. Now we're going to go 9 volts more negative, and you can see there's a negative. So it doesn't look like it provides as much current to the negative as it did to the positive. Now we're going to go up to this jumper and test this one out of this op amp. So that's the output of the other op amp. And so, yep, about 26 again. and a little less than 24 again. That one looks like it's holding a little more steady. So that's the short circuit protection, and that is it for short circuit protection testing. So I'm going to make sure I get this off of milliamps, and I think I'm actually done measuring voltage. I can show the voltage of these resistors. They're in relationship to the negative rail, so 9 volts, and then going to the resistors there, it's 9 volts there, and that is what our output is right there. So that's in relationship to the negative rail. If we go to the positive rail, of course, it's negative 9 volts at that point. So that's how we set it. So I did a couple other videos where I showed that too, step-by-step builds, but hopefully that makes sense. And so in any case, it's just 2 op amps in one integrated circuit, and it also has the offset null options. Other ones are just, they put 2 of them onto the same 8-pin integrated circuit, and all you have is the power pins and then the 2 op amps without the offset null. So this one has it if you need it, and you need a double op amp. This is a good way to go, it looks like. So in any case, hopefully I'll come up with some interesting videos using it. Thanks for watching. I will see you in the next video.